So the next question is that we have a ring and it has a charge density lambda equals to lambda naught cos theta, and we have to find the electric field at the center. That is the question. Find electric field at the center of ring for the given charge density. So first you have to analyze how the charge is spreaded. Cos is a function which has first and fourth quadrant positive results we get. So the right half is completely positive and the next left half is negative. So this first quadrant and third quadrant will contribute towards this field, and this fourth quadrant and second quadrant will contribute towards this field. So if we see, we can calculate for these two quadrants and and one direction. So if I take a small element, say at an angle theta, I take it as d theta. So this is the line we are creating, and this is the vertically opposite angle theta. So for this small portion, only this one portion, I get electric field towards the third quadrant. Also, similar portion can be drawn here, and it will also draw towards this direction only because it's minus sign. Minus sign, for minus sign, the electric field towards the minus sign. So these two are getting added. Okay, so we get electric field in the third quadrant, towards third quadrant. For that we can write 2 dE. These components will be gone, the sine theta components. For this also I'll get an electric field in the second quadrant, and minus sign will also have an electric field towards itself. So if you see, both are symmetric, hence this direction will have a component perpendicular direction, and there is an x component in this direction, which was similar to the component due to the first and third quadrant. So we can see that the cos theta components are getting added from both the regions, and the sin theta component getting subtracted due to symmetry. So I can write it as that dE sin theta. If you see, there will be dE sin theta, there will be dE sin theta. dE sin theta will be cancelled out, and due to first and third regions, there will be a dE cos theta component. Sorry, I have written 2 dE cos theta, and due to the second and fourth, there will be another dE cos theta component in this direction. So I'll have actually two. The total dE net can be written as dE net can be written as 2 dE cos theta. Now, if I want to find out the E net, I will have to integrate this dE cos theta. Okay, from this region to upper region, that is from minus pi by 2 to plus pi by 2, because the entire charge is spread like this. Okay, so I can find 2 dE will be k dq by radius square cos theta. Now we have 2 k by r square. dq can be written as lambda dx. Okay, cos theta minus pi by 2 to plus pi by 2. So we have 2k as 1 by 2 pi epsilon naught r square, and lambda is written as lambda naught cos theta, and dx can be written as, this is dx, this is r d theta. So I'll get r outside, and lambda naught can also be written outside. So we have a cos squared theta, because cos is already there, and one cos comes from lambda. Lambda naught have taken out, one r also have taken out from dx is r d theta. I'll write it here, dx is r d theta, and lambda is lambda naught cos theta. So lambda naught and r have taken out, cos theta d theta are emerging from this expression, cos theta and d theta, minus pi by 2 to plus pi by 2. So we have lambda naught. Okay, lambda naught I've written twice. This goes gets cancelled, and now we can solve for this expression, which is cos square theta. So I will write integration of cos square theta is 1 minus cos 1 plus cos 2 theta by 2, and I'll separately solve it here d theta. So 2 can be taken outside, it will become 4, and 1 plus cos 2 theta will become theta plus sine 2 theta divided by 2 minus pi by 2 to plus pi by 2. So we'll have lambda upon 4 pi epsilon naught r. Pi by 2 and minus pi by 2 will become pi plus half of sine 2 into pi by 2 sine pi minus again sine pi. So because sine of minus theta is minus sine theta, this can be cancelled. Then pi gets cancelled, and the answer would be lambda upon 4 epsilon naught r. Okay, that is the answer to the question.